you should notice, I didn't know we were going to go off the map. There are topographical maps and numbers running along the outside of the map. Okay, these are the maps. I know you can't see very well. These are the maps I use in my classroom. There's numbers running all along. These are a 7.5 minute map, the same maps that CalTOPO will give you, but this is just a much larger size for the students to use in the classroom. Okay, the latitude, longitudes are along the side. There's two other grid systems, which is the public land survey system. This was Thomas Jefferson. After the Revolutionary War, he decided to take the land and hand it out to people. The people got to go out on their horses, grab onto a pole, and claim the section that was in the middle of the pole. It's really cool. And then the UTM is used by the military. I don't teach the UTM in my classroom. I do teach public land survey system, but mostly what we're going to talk about is latitude, longitude. This is latitude. Lat lays flat. It's along the equator. Longitude is longitude. That's how I try to get my students to remember. This is the prime meridian, and it runs through Greenwich, England. Greenwich, England got to name it because back in the day, England was the Navy Empire. So they got to do the longitude line. The latitude line runs flat across here. The latitude line measures north and south. The latitude line measures west and east. This right here, my fingers are the prime meridian. It goes all the way around like this. So you'll only get 180 degrees longitude line. It'll either be west or east. Now latitude starts at 0 and it goes up to 90. Starts at 0 and goes to 90 south. Okay, latitude, longitude are in the corners of each topo map. The exact latitude, longitude is given at each corner of the map and spaced intervals between the corners. Degrees are not accurate enough to find a precise location. At best, 1 degree of latitude and longitude will define a 70 square mile area. Okay, this is 35 degrees, 15 minutes. It's based on a clock. 15 minutes, and then it'll go to 29 seconds. Okay, 35 degrees. This way is latitude. This way is longitude, just like this. Okay, 1 degree is 70 miles. We live at 46 degrees north. If any of you are skiers, downhill skiers, or snowshoers, and you want to go to 49-degree snow ski resort, it's 70 miles times 3, about 200 miles as the crow flies to get up to 49-degree north. Kind of a point of interest. 1 minute equals 1.2 miles. 1 second is 0.02 miles. This becomes important because most of the maps you'll look at are 7.5 minute maps, quadrangles. Right here on the corner of this Mount Rainier, one of my favorite maps, it'll say 7.5 minute quadrangle. That means 7.5 minutes times 1.2 miles. It's about a 9-mile map. Squared up. Latitude, it'll be squared up this way, and longitude, it'll be squared up this way, okay? 7.5. This latitude and longitude on this line is, latitude is the one that goes this way, 37 degrees, 37 minutes, 30 seconds north. 121 degrees, 30 minutes west. This is really important. All of our maps, unless we go to the southern hemisphere, will be north. They could be east, but for us in our area of the United States, it's always going to be north, and it's always going to be west. Okay, minutes on a map. You'll notice a 7.5 minute map. This means that the map covers an area of approximately 7.5 minutes. Recall that 1 minute is 1.2 miles, so this map is about a 9-mile map. If you use CalTOPO, At the end of this presentation, you'll see a site that you can go to CalTopo, and they will ask you, they talk a lot about the 7.5 minute map. Okay. This is important. This is the ratio scale, 1 to 24,000. It's important. 1 to 24,000 is what I would use if I was going to do a map. 1 to 50,000, 1 to 24, if this is your land, this is your map, land, 1 to 24 might be here, 1 to 50,000 is here. You're going to see more, but it's going to be harder to see. 1 to 62,500 is clear up here. You're going to see more, but it's going to be harder to see. The contour lines are going to be smaller, okay? The graphic scale, this is really important right here. The graphic scale between here and here is 1 mile. In a minute, I'm going to show you how to take measurements on a map using a piece of string. The string takes it from here. You can bend the string to go here, bend the string to go here. You take that string, straighten it out, come up to the graphic scale here. And if your string goes from here to here, you will know it is 1.3 miles, because on the left side of the 0, they scale it out for you in tenths of a mile. So this is 1.1, 0.2, 0.3, etc. Here's feet, and it scales it out for you even better here. And then here's kilometers, and this would be 1 kilometer, 1.1, 0.2, etc., etc. This information at the bottom will always tell you the contour interval. Sometimes you can figure it out though. Sometimes your maps might not give you a contour interval, and it's easy to figure out. I'll help you figure it out. I'll show you. Okay, this is a 1 to 24,000 map, 24,000 scale. You can see the contour lines. All of these contour lines on Mount Rainier, right up here. Every 5th line is thicker. This would be 13,600. This one is 13,800. I'm following this contour line around to here. As long as you stay on the contour line, you're going to walk even. You're not going to go up and you're not going to go down. This contour interval is about 50 feet. That's how you sometimes, if you don't have it at the bottom, you can figure it out. Where's my cursor? Okay, there we go.